Hello my friends, and here we go with this new step of the training implementation, implementing the DQN class. And check this out, we're almost done with part 2 implementation, training the AI. After that we'll have part 3 visualizing the results, which I remind we won't implement together because this is not really essential to knowing how to build an AI. This is just a visualization code, so we won't re-implement this together, but that's great. I can't wait to show you the final result. We are on a very good way to build a powerful AI that is able to land on the moon. So here we go with that new step, implementing the DQN class. So let's do this. Let's create a new code cell, and our first step will be to create a new class, which we're going to call agent, or you can call it AI, or you can call it body, to oppose that to the brain we just made before in the network class. But let's keep the usual names that are commonly used in practice, which is agent. So here we go. Let's create this new class, which we're going to call agent. Nothing to specify in the parenthesis, colon, and here we go with the constructor method to initialize the agent object. I'm talking, of course, about the init method. All right, so what is it going to take as argument? Well, first self to refer to the object. Then it's going to take the state size and then the action size, which I remind for our environment is 8 for the state size and 4 for the action size. All right, then let's add a colon, and here we go. So first, the first object variable we're going to create is the same one as we created before, self.device, just to give us the choice if we want to use a CPU or a GPU. For example, if you want to use this implementation outside of Google Colab. So what we'll do to do this efficiently, and because we did it before, we're just going to take this line of code because it's going to be exactly the same, copy it, and then right here, we're going to paste it. Okay? No need to do it again. We understand how it works. Then, next object variable is going to be, of course, the state size. So remember, this is the argument, but we still need to create the object variable. Whenever we create a new instance of the agent class, well, we need to define those variables proper to the object. And the first one we're going to create now is self.stateSize. And then, of course, it will be initialized to the state size argument that will be entered later on in this class instance. All right? Then, next object variable is going to be self.of course action size. So that's the object variable, and then we'll initialize it to the argument action size, which will be entered later on when we create the object, meaning instance of this agent class. And by the way, remember that we already initialized the variable for the action size, which we called number actions, right? This is exactly the same one when we set up the environment. Number actions here is exactly action size, the size of the action space. So if you wanted, to make everything clear and the same names, you could also name the object variable number actions, okay? But it's good to work with several names. At least you know that action size is actually the size of the action space as opposed to the state space. So there we go, self-action size equals action size. Now, according to you, what is the next object variable we have to create? Well, there we go. It's time to do a little bit of Qlearning here. We haven't introduced any Qlearning so far, so now is the time. And so, how we're going to do this? Well, we're now going to create two Q networks, the local one and the target one. Remember, as in deep Qlearning. And how we're going to create them? Well, remember, we created our network class before, and so we can just simply create two instances of this network class, one that will be the local Q network and one that will be the target Q network. So here we go, let's do this. Let's start with the local Q network. So I'm going to call it local Q network. And as we said, it's going to be created as an instance of the network class which we created before, and which contains indeed those arguments, because remember, it inherits from the module class by the NN module. And actually, since we already provided a default value for the seed, we just need to enter those two arguments. So right here in the network class, I'm going to paste them, and that's it, because these are actually the arguments of the object. All right, perfect. And then remember, we need to add this, meaning two parentheses self.device, in order to move it to the designated device, GPU or CPU. Perfect, and now let's do the same for the target Q network. So I'm pasting the line above, and I'm going to replace local here by target. And it's going to be initialized exactly the same way. Okay, then next step. Now that we have our network, what do you think we should create as an object variable? Something very important for the training of our AI. Do you know what it is? Well, I'm talking, of course, about the optimizer. So the next object variable I'm creating here is self.optimizer, and we will create that object as an instance of the Adam class, which allows to build the Adam optimizer. All right. So the Atom class comes from the Optim module. And there we go, from the Optim module, I'm calling the Atom class, which will take as arguments first the local parameters, meaning the weights of our local Q network. So we're going to take our local Q network here, self.local Q network. We're going to paste that inside the Atom optimizer, and then we're going to call an attribute of this local Q network, which is parameters, and which are exactly the weights of the network, meaning what we will update step by step to predict better and better actions to play in order to land properly on the moon. So parameters, and then there is one more argument, very, very important for the training, and we can see it here very well highlighted. I'm talking, of course, about the learning rate. All right, so we add here LR equals, well, this will be equal to the learning rate variable we initialized before in this part 2. Learning rate, there we go. Then next step, okay, so we took care of the local and target Q networks and the optimizer, and now according to you, what else do we need in order to implement that DQN class? Well, that's of course the memory of the AI, thanks to of course our replay memory class. And so I'm creating this new object variable self.memory, which will be initialized as an instance of the replay memory class, which will of course take as argument, remember, let's have a look again at our replay memory class. It takes as argument the capacity, you know, when we create an object. And what is the capacity? That's something we also initialized before. Here it is. That's of course the replay buffer size, which has a capacity indeed of 100,000 experiences. So I'm copying this, and then inside that DQN class, I'm going to enter it as the argument of the replay memory class. Alright, and now we have one final thing to do in this init constructor method. That's just a final object variable we need to define and initialize for the rest of the training, which is the time step. Alright, the time step counter, you know, for deciding when, you know, in which moment we're going to learn and update the network parameters. So how do you want to call this? You can call it time step or T step. And of course, we will initialize it as 0. Alright, and that's it. That's it for the constructor init method. Now we have all the object variables we need to implement that DQN algorithm. And that's exactly what we'll do in the next 4 tutorials. Indeed, we have 4 more methods to implement here for this DQN class, so we'll do 1 method per tutorial. So I can't wait to see you in the next tutorial for implementing that next method, and until then, enjoy AI. Hello my friends, and welcome to this new tutorial. In this one, we're going to implement a new method of that agent class, which will be the step method. And this is a method that will store experiences and decide when to learn from them. Alright, so let's do this. We're going to start with def to define this new method. Then we're going to call this new method step. And then this new method will take as argument, well, first self to refer to the object. But then, as you might guess, it will take the experience, right? Because first this method step stores experiences. However, we're not going to directly input here experience. We're going to decompose the experience into its different elements: state, action, reward, next state, and done. Alright, so that's going to be the arguments of the step method. Then let's add a colon, and there we go. Let's implement it. So the first thing it's going to do is to store the experience in the replay memory. And therefore, since we already created our memory object with self.memory as an instance of the replay memory class, well, we're going to call our self.memory object. So I'm taking it here, and then I'm pasting it right here. And then remember, in the replay memory class, we also implemented the push method that stores an experience in the replay memory, and therefore, of course, we're going to add a dot here to call the push method from this self.memory object. Then we add some first parentheses because it's a method, a function, but then we're going to add another pair of parentheses because we have the experience decomposed like that. So in fact, in order to enter the experience here, well, we're going to enter the whole tuple of the state, action, reward, next state, and done. So I'm taking this, and just inside, I'm pasting it. All right? Perfect. Now, next step. So remember that this step method does 2 things. First, it stores the experience, so that's what we've just done. But then also, it decides when to learn from the experience. And so basically, what we need to do now is increment the time step counter, which is one of our object variables here, self.tstep. We're going to increment this time step counter and reset it every 4 steps so that we can learn every 4 steps. All right? And we will learn with another method that we will call the learn method, and that we will implement later on in this agent class. So what we're going to do here is take this self.tstep object variable, and then just below, we're going to paste it because we're going to update it by first incrementing it and then resetting it every 4 steps. So first let's start by incrementing it, meaning adding 1 to it. And the way we're going to do this is very simply paste it again and then add +1. Alright, so that's the increment. We increment the time step counter. But now we also want to reset it every 4 steps, and we're going to do that in the same row. And well, the way to do that is to use modulo. I don't know if you know this. If I put some parentheses here and then add a percentage and then 4, well, all this exactly means the rest of the Euclidean division of self.tstep plus 1 by 4. Meaning, if self.tstep plus 1 is divisible by 4, then all this will be equal to 0, because the rest of the division would be 0. And therefore, that checks if we are every 4 steps. Alright? So, new step done, good. And now, time for the last part of this step method, the learning, which would happen only if we have reached 4 steps, every 4 steps. And therefore, what we need to do now is an if condition that checks if we are every 4 steps. And the way we're going to do this is, of course, with if, and then self.tstep. And now, since self.tstep is actually equal to the rest of this division by 4, then the way to check if we have reached a new 4 steps is just to do this if self.tstep is equal to 0. Alright? And so, if that's the case, then what are we going to do? Well, we're going to learn, because we want to learn every 4 steps. But then, remember that when we learn, we don't learn on one observation only. We actually learn on a mini batch of observations. That's why we created the mini batch variable before, which we initialized to 100. And therefore, what we must do first before learning in the step method is to check that the number of experiences in the memory is already larger than this mini batch size of 100. And therefore, we're going to continue here with another if condition, which will check if the length of our self.memory object, but more specifically it's going to be an attribute of that memory. So first let's paste self.memory, and then let's get a quick refresher of what we did in the replay memory class. I'll show you that it has a specific attribute which is actually the memory, and it's actually not to be confused with the self.memory instance of that replay memory class that we just created here. So basically, simply put, this is the instance of the replay memory class, and then in order to call the memory attribute that we see here, well, we just need to add .memory here. Okay, so this is the object, the instance of the replay memory class, and this is the attribute of this self.memory object. Alright, I think it was important to clarify this, but there we go. So now we have the memory size of our memory, basically. And so, if that memory size is larger than the mini batch size, which we also created and initialized before right here of 100, well, in that case, we can learn. We can learn on 100 observations instead of just one observation. In AI and reinforcement learning, we always learn on a mini batch of observations as opposed to one observation. And so then let's add a colon here. And so if that's the case, well, what do? First, we're going to get our experiences. So I'm creating a new local variable here, which will contain this mini batch of 100 experiences. And how am I going to get them? Well, I'm going to use, of course, another tool we created before, which is the sample method from the replay memory class. And so to do that, I have to take my self.memory object, the instance of the replay memory class, and then from this object, I'm going to call that sample method, right? Which will sample 100 experiences from the memory. And it will find them because we check that the size of the memory is larger than the mini batch size of 100. So there we go. Let's enter 100 here, of course. And so now we have our experiences, and therefore the last step is to learn from those experiences. And of course, we're not going to implement the learning algorithm right now. We'll do that in a separate method. But since we will call that method learn, what we can do now is actually to call this method learn, which will be implemented in 2 tutorials, and which will take as input, of course, our sampled experiences, but then another one, which is the discount factor gamma, which remember we called discount factor, or maybe you called it gamma, when we initialized the hyperparameter. And that, what we did here to call the learn method even before defining it, is totally fine as long as, of course, we define it after in this agent class. Alright, so there we go. we're done with this new step method. Now we can move on to the next method, which will be the act method, which will be, of course, the method that will select an action based on a given state in the environment. I can't wait to implement this new method with you in the next tutorial, and until then, enjoy AI.